Okay. Assalamualaikum warahmatullahi wabarakatuh. And a very good day to everyone. Welcome to my class. This is my lecture. For topic 4, I'm going to cover another part of topic 4, which is for this time. Okay, basically, let me recap first. Previously in topic 4, we do a balance and a balancing mass. Let's say we got one good amount of shaft, and then we're going to have a balance mass around the what you call that, the satah, or what you call that, the angle of the shaft itself, where it circulate around the shaft. Okay, so that's the thing. It means it rotates around the plane of the shaft. However, for this case, nowadays, for this time, this topic basically is a bit different, where we got a shaft, from point A to point B. Okay, so we're going to balance out throughout the length of the shaft. So we got mass A, mass B, and mass C. So it goes around the length of the shaft, which is from point A to point B. Then you got the mass to be balanced out in perpendicular to the length of the shaft itself. Okay, so this is the kind of like extension topic for topic 4. Okay, so I'm just going to jump to the question. Very easy one. As you can see, this is question 8. All right, where it's stated here, a system has rotary masses which happen to be in full dynamic balance processes, magnitude of 5, 6 m and 8 kilo. Means you got 5, 6 m and 8 kilos of masses that rotates around the plane of A, B, C, and D. The respective plane B, C, and D are at the distance of 0.3 meter, 1.2 meter, and 2 meter from plane A. Means plane A is a my bad. Plane A basically is the reference plane. Okay, each of masses is at the similar radial distance. Means each of mass is similar radial distance of 0.3 meter. Okay, determine the magnitude of m along with the relative angular location of all masses stand for entire balance. Okay, so first step, mostly in my class, I always I always remind my students to what I call that, to always highlighting every single details of information that given throughout the question. So more or less, it's going to be great if you can work out with a table where you want to put first column is the plane, plane A, B, C, and D. Okay, and then you're going to put mass, which is m, and with a unit of kilogram, you got 5, 6 m, and 8 m is unknown. This one we don't know. Okay, And then since it clearly stated here, similar radial distance of 0.3 meter. So, you know, just imagine this is your shaft. Front view, front view. This is your shaft. So you got here, 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 and here. The radial is 0.3 meter. Yeah. This is from front view. Front view is pandangan sisi hadapan lah. Yeah. Okay. So it's clearly stated here that the the mass is 5, 6 nm and 8 kilogram. The radius is equivalent with a magnitude of 0.3 meter. Okay. So once you manage to get these three, wait up. Once you manage to get these three so-called information, these three columns of information where you go by plane, mass, and radius. So it's going to be much more easier for you on the fourth column to equate with the mass multiplied by radius. So very easy one. 5 multiplied by 0.3, you're going to get 1.5. Carry on, and of course, m multiplied by 0.3, you got 0.3 m. Okay. This 1, 2, 3, 4 planes is the one that we already discussed and explore in our previous lectures. Yeah. So now for this lecture, we're going to exploit and explore for the 5th column and the 6th column. Okay. So for the 6th column, the column number 6, basically what they want is to know the distance from reference plane C. Okay, what does it mean by the reference plane C? Okay, here clearly, let me draw it for you. Okay, basically the respective plane B, C, and D are at distance 0.3 meter, 1.2 meter, and 2 meter from plane A. Okay, so basically, this one need to be drawn. You need to draw lah. Okay, so you need to draw it like this lah. Okay, from point A to point B. See, from point A, okay, the respective plane B, C, and D are distance 0.3. So means from point A, from mass A here, from mass A to point B is 0.3 meter, is 0.3 meter. And then from point A to point C is 1.2 meter. It's shown clearly lah. It's shown here. From this point to this point is 0.2 meter. Okay. And then from point A to point D is 2 meter. Here is already stated lah. From point A to point D is 2 meter lah. Okay. It's 2 meter. Very clear. So you got point here to point here. Okay. However, the very big question is, from plane each of mass is from. So now the question is, we don't know plane C. What is the mass of plane C? We don't know. here. For this case, yeah, let me go by good color. Okay. For our case now, here, we don't know what is the mass. So, practically what they do in our syllabus, we're going to put RP, and we're going to put C as a RP. Yeah, reference point. Okay, so if it move to the right, it's going to be positive, and it move to the left, the distance, yeah, what I mean here, if move to the left, it's going to be negative. All right. So for our case now, let's fill up the plane, no, the column, the fifth column, the column number 5. Let's say, I think beforehand, before we proceed, I think column 1 up until column 5 is covered lah. This one you already know lah how to solve. So now our focus is column number 5. So basically, distance from reference plane C. So A to C. So here you can see A to C. Yeah. So basically, you're not going to count. You're not going to start from A. You're going to start from C. So it basically from C to A. So what's supposed to be the length? Okay, the direction is on the left. So basically, going to be negative. And then what is the magnitude? The magnitude is 1.2 meter. Therefore, the overall value is supposed to be negative 1.2 meter. So that's why we get this value. Yeah, 1.2 meter. Same goes from C to B. Yeah, from C to B. Okay. From C to B, you can see C to B. What's supposed to be the angle? No, what's supposed to be the dimension, the distance? So this distance basically, sorry, I try to make it more readable. Basically, this distance is 1.2 meter minus what? 0.3 meter. Therefore, it's going to be equivalent to what? 0.9. Okay, 0.9 meter. And since it supposedly moved from point C to B, as we know, C is the reference point. Therefore, we're going to put negative 0.9 meter. Okay, so basically you're going to determine the distance from C to A and C to B. Okay, and then afterward you're going to know the distance from C to D. All right, from C to D basically is very simple. The formulation is supposed to be 2 meter minus with 1.2. Okay, so basically you're going to get about 1.8 meter. Does it sounds right? And then since it moved to the right, so it's a positive lah. Okay, so that's why you got, from C to D is 0.8 and negative 0.9. And of course, from point C to C, here, from this point, From this point, it doesn't move anywhere, either to the right or either to the left. So the value is determined to be no value lah. No, it to be 0 lah. It doesn't have any distance at all. Okay. So now at the moment you already have the distance from plane C. Okay. Therefore, you're going to manage to get the 6th column. You manage to get the 5th column now, yeah? Selesai. Okay, done. Now we're going to go for our 6th column, yeah? The 6th column is very simple, I think. Okay. Wait out, 1.8 multiplied by 0.9. Okay. So once you manage to get once you manage to define the 5th column, so now your job is much more easier. It means that you have to solve. You're going to manage to get the 6th column. Yeah, the 6th column is just a value where you're going to what? You're going to multiply this value m r multiplied by l. mr multiplied by l. mr multiplied by l. mr, wait up, and then mr multiplied by l. So this is all the value. Oops, my bad. This is all the value that you're going to get in order to finish the whole table. By having the table, I think you'll be good to go. Okay. So now you already done the table. So still you not solving the problem yet, since you still don't know what is the value for m, yeah, for mass m, but it's still okay, no problem. This one we're going to what I call that? We're going to draw lah. We're going to draw the linear polygon lah. Okay. So what is the question? Determine the magnitude of m along the relative angular volume. Yeah, okay. Okay. So this is the angular position. Let's say we start from A lah. A is 0. And then what's supposed to be the angle of B? Yeah. So what's supposed to be the angle of B? Does it give you any? Okay. Okay, let's check, yeah.